right, if you are interested in learning machine learning, you do machine learning right now at work, this is absolutely the segment for you. We've got a real treat here. We've got Shankar from NVIDIA that's going to talk about NVIDIA Triton. But let's do some intros first. So my name is Jillian, and I'm a startup solutions architect at AWS, and I've got the fabulous Steve here hosting with me.
Flattery will get you everywhere. Hello, everyone. I'm Steve. I'm a developer advocate for .NET and PowerShell at AWS and a self-confessed machine learning newbie.
Perfect. And Shankar, yeah, please say hi.
Hi, everybody. This is Shankar again. Thanks, Jillian and Steve, for having me. I work at NVIDIA, and I look at product marketing for Inference portfolio, which includes Triton Inference Server.
Yeah, so before we dive into NVIDIA Triton and Inference, I think we should maybe first level set with everyone. We've got a couple newbies. This is a safe place. So what is Inference?
Yeah, it's a great question. So Inference, so we're talking AI or machine learning, right? So there are two phases in an AI workflow. The first is training or development. This is where a lot of us develop models using one or more frameworks, machine learning or deep learning. Now, once a model has been developed and trained, it's ready to put in production, right? And that phase is called inference. Inference is where the model is sort of going to work, right? And it's predicting based on new data and based on what it has learned in the training phase. So that's inference. Inference is model running in production, doing predictions, and this is where we see the real value of AI.
So as somebody who's like new to ML, which I self admit to, is in the outside world, where might I see inference being used?
Sure, yeah. So inference is about deploying models, right? And you can deploy models pretty much everywhere. You can deploy it on a public cloud like AWS as an example, or I might decide to deploy models on an on-premises data center, right? Or I could even put the model at the edge of a network or even on an embedded device, right? And this is where we see certain use cases in manufacturing and other industrial locations, where they may want to run the model actually on an embedded device at location. So there are several different places where we can deploy these models. And also this is where, it really depends on where it makes sense for the business.
Yeah, that's the exciting part, getting that model into production. But a common question that I get a lot from the startups that I work with is, all right, I've got that model in production, but the performance, it's not what I need it to be. So tell me, what are some things that I can do to improve the performance?
Sure. I think maybe we can expand that question a little bit. Like, what are the challenges that people face in putting models in production? I may have a slide that I can use as a prop to, basically walk through them.
Yeah, please do.
Yeah. So if we can put this slide on. Okay. So I mean, this is a good framework for us to understand, right? First is we talked about what inference is. Now, within inference, there are two phases or aspects of inference itself, right? Where a model is trained, typically it goes through an optimization phase. This is where people are saying, okay, let me see if I can make the model smaller. Can I put some other, acceleration into it? So the goal being how to make the model run faster, right? Or maybe run the model with a small memory footprint. Or maybe, there are a lot of constraints that basically we can make trade-off using in this optimization phase. So let's say we have done the optimization. So we've got an optimized model ready to run. And then comes the part of putting it in production. So basically, we're deploying the model. It could be in a container, or it could be in a framework like SageMaker. And then the inferencing starts, right? So at this place, or at this point of inferencing, there are several challenges that we have to consider. For example, now imagine we're working in an organization. We have a lot of applications, and applications are using a lot of different models for different use cases, right? Now, the one thing to note is not all the models are the same. So we have some deep learning models that are neural net based. There are some classical machine learning models, right? And there are some models that are so large that they need more than one GPU to run. So we can clearly see that, deploying these different types of models can be quite complex in production, especially if you want to get good performance from them, right? That's the first challenge. The second challenge is really on what we call app constraints. So a model can run in real time. That means when an application is let's say sending a request to the model, it's basically waiting for response. So that's real time. The model needs to crunch the numbers and get back to it immediately. The other could be it's an offline case. Offline case is when the application is saying, here are 1,000 predictions, make them offline and get back to me with the results, right? So here there is no latency, is not a problem, but you will have to process that many requests in, let's say, in a given time.
So Shankar, I just wanted to ask you that you mentioned real-time prediction. I'm assuming that's like kind of like, I'm watching my favorite sport and it's going to say, hey, the probability of an overtake in this race is going to be X%. That's a real-time prediction from Inference, right?
Exactly, Steve. Yeah, that's real time, where you're actually doing the processing right when you're requesting, right? Another example is, let's say we go to a website like Amazon.com, and if you're searching for a product, it gives you all these products, and then it gives either suggested, recommended products. Those are all real-time predictions. You have to happen while I'm waiting there on the website. Absolutely.
Okay, got it.
Good, cool.
Speaking of Amazon.com, there's even a blog post that we'll share about how Amazon search is using Triton to improve the performance of their search algorithm for production.
Exactly. I think Jillian, that's a great point. In fact, that's a very good success story. I think so. Amazon search. So when I go to Amazon, like when we all go to Amazon, we are searching in the product in the search box, right? I'm looking for, let's say, a football. If I misspell football, Amazon knows to correct it and still show me the best results, right? So, imagine the customer experience. If I misspelled some word for whatever reason, if I get the wrong set of results, that's going to impact my experience. So this Amazon spell checker makes sure, regardless of how I spell, it's going to correct it and still show me the right results for me, right? And that's really an AI model that's running behind the scenes that's doing this spell check, right? And that model is run using Triton on GPUs, and that's a very good use case of a real-time prediction.
Okay, so now that we've mentioned Triton, let's talk a little bit more about what is it and how does it help with these challenges?
Absolutely, yeah. So let me go to the next slide. I think that's what is Triton, right? So Triton is what we call an inference serving software. Think of it as software that's running in production that's basically serving models. We have this concept of database servers, web servers. Web servers serves pages, and so Triton is serving models or inferences, right? So that's what Triton is. Triton loads all these models on CPUs or GPUs. And when an application says, okay, I need this model to run, it's basically sending a query to Triton, says, Triton, run this model for me. So Triton is basically going to run the model on the underlying processor and send back the result to the application. So that's at a very simple terms what inference serving is, right? It's like a client-server architecture for inferencing. And the way Triton simplifies those complexity we saw before is by providing all those functionality out of the box. For example, Triton supports all the frameworks natively. So it has the TensorFlow backend, it has a PyTorch backend, XGBoost, and so on. So if let's say we are a team of 3 teams, they all use different frameworks, but they can all standardize on Triton in production because Triton knows how to handle all those different frameworks, right? That's in one example. So Triton, the other example is you said real-time and batch. Triton supports both real-time processing and batch processing. So it can cater to both use cases, in the same fashion. And it runs on, as I mentioned, GPUs. So Triton runs inferences on GPUs, which is graphic processing units that are basically accelerators for AI. But it also runs or can run on inference on CPUs. Today, we all know that CPUs are pretty much everywhere, and a lot of inference happens on CPUs today, right? For ease of use and for different reasons. And so it's very easy to start with inferencing on CPUs with Triton, and organizations can migrate to GPUs, let's say, for better throughput or latency on their own timelines. That migration is pretty seamless.
No, it's interesting you said that because I, again, as an ML newbie, I assumed that all of ML and inferencing required a GPU. I did not know you could run it on a CPU.
Right. Yeah. It's not required. Yeah. That's in fact today. We see a lot of people use GPUs for training, right? For reasons because training requires a lot of iterations on the model, right? It's a very iterative process, and they need to, and these models, and so that takes time. It requires a lot of computing power, so it makes sense for them to use GPUs for training.
Yeah.
Now, inferencing also has a lot of benefits on when run on GPUs, but doesn't have to be. We can always start on CPUs today, like with Triton. In fact, Triton supports, for example, OpenVINO backend. OpenVINO is Intel's compiler for like we talked about optimization phase and inference. It makes sure that model is optimized on the Intel architectures. So it supports OpenVINO. So you can even use OpenVINO, run it on CPUs, and then you can even have an heterogeneous, like you can have some models run on CPUs, some models run on GPUs. Triton can handle them. Triton knows. So when Triton is run on a server, it knows, does it have CPUs? Does it have GPUs? How many GPUs does it have? So it has all the logic. So the calling application doesn't have to know. You say just run the model. As long as the model, let's say the model is GPU accelerated, it knows it can use the GPUs. Or you can say, run it on CPUs. It knows like it runs on CPUs. So it's very easy to use Triton. The calling application doesn't have to know the complexities of the underlying infrastructure.
Cool.
Yeah, and there's a lot of different places that you can run it on AWS. Yeah, there's the market, and we'll send those links. Marketplace. There's another blog post on SageMaker, running it on SageMaker.
Yeah, absolutely. Yeah. I think I'm very happy and proud to say that Triton is very well integrated in AWS stack. So like starting from SageMaker, SageMaker has an option to use Triton. So anybody who is using SageMaker for their ML development and deployment can choose Triton to run their models. So that's available. And Triton is also can work with EKS and AKS. EKS and ECS. Sorry, and so if people are using managed Kubernetes on AWS, they can very easily use Triton in that cluster to run inference and models. And of course, you can always run Triton with their EC2 instances, CPUs and GPUs. So it's available across all layers of the stack. So it gives people like the convenience to use Triton depending on where they want to use.
All right. So back when you were talking about CPU and GPU options, one of the things that crossed my mind was, given that Triton is dealing with all this for us, the infrastructure that's under the covers, whether I'm running on CPUs, GPUs, it seems like it would be something that would be really easy to migrate to. Is that true?
Yes, Steve, absolutely. I think that's been the design philosophy of Triton is make it easy to deploy models. Is basically meeting the customers where they are, right? Meeting organizations where they are in their AI lifecycle, in their stage of AI. So most people, like I said, they would prefer or to start with CPUs and then maybe migrate to GPUs for let's say a bigger model or for a different use case. And this is absolutely perfectly supported with Triton. And so Triton from the get-go supports CPUs. CPUs are first-class citizens in Triton, just like GPUs. We support both x86 and ARM CPUs. So if an organization, let's say, wants to start on CPUs, yes. So they can train the model on any framework, like we mentioned, and use Triton to run that model on a CPU. They will still get all the benefits that we talked about. They get best performance on CPUs too. And when they're ready to go to GPUs, it's very easy. They just have to go to the model config file and say, I want to use GPUs. And so Triton knows how to run the model on GPUs. So there's no very, very seamless change from one to the other.
Yeah, I know there's definitely a lot of people that really want to try this out. I hear it all the time from machine learning startups I work with, like, how do I improve the performance of my model? So really, where's the best place for them to start learning how to implement Triton, where they can go to learn more and get started?
Yeah, there are a couple of places. I think the website, we can put it on the chat, is the first place to start. It's a developer website on NVIDIA, on Triton. It's got a lot of good resources to getting started on Triton, basic guide, a very simple use case to start with. And then it has got a lot of tutorials, both videos and otherwise, just as they advance. There, as part of the inferencing, we mentioned the optimization phase before. So TensorRT is our product or software for that. And it is part of the inferencing stack. So let's say a team is ready to go to GPUs and they want to have an optimized model. they can learn about TensorRT too. There is a developer page for TensorRT. We'll put it on the chat. And so they can go learn about TensorRT, and they can then use that model in Triton. That's one place. And of course, Triton is completely open source. So, anybody who wishes to go and, let's say, work with the code, they can go to GitHub. We'll put the link there so they can go extend, customize, verify, modify, free to do so. They can contribute back to Triton too as an open source project. The other thing, so Triton has a monthly release. So every month we come out with new features, bug fixes, and so on. So if you're looking to stay up to date, there is a sort of a newsletter community that they can join. And as part of that newsletter, they're going to find out what's the latest in that monthly release, what are the key bug fixes, any tips and tricks on using Triton and TensorRT, and any relevant content like tutorials and notebooks and demos and so on. So it's a very useful newsletter for them to get started.
That's awesome. And then definitely make sure you check out, we've got a link in NVIDIA Triton on the marketplace. We've also got it on SageMaker examples on AWS's GitHub. And there's also 2 blog posts that talk more about NVIDIA Triton. Wow, so this has been fantastic. I'm sure people are just ready to go and start building right now. Shankar, thank you so much for sharing all this information with us. And of course, Steve, love the questions. I'm sure all the other newbies are like, oh, thank God Steve asked all these questions for us.
I'm loving my ML journey.
All of us are. All right, thank you so much, everyone, and stay tuned for the next segment.